Hello friends, in this video I am going to explain the design and simulation of an active narrow band reject filter or a band stop filter, which is also called twin T-notch filter by using multisim software. As that name suggests, band reject filter is a filter which is used to reject the band of frequencies between two cutoff frequencies. So here I am going to design a narrow band reject filter. That means a circuit which rejects only the small portion of the frequency spectrum, that is narrow bandwidth. As you can see over here in the frequency response, it is rejecting only this range of frequency. It is not allowing the signal to pass through the circuit only between FH and FL. So this bandwidth is very narrow. So it is also called a twin T-notch filter. So in this case, it is called notch filter because this symbol resembles the symbol of a notch. Now this is the diagram. As you can see over here, I am using one op-amp and capacitors with the value C. The resistor value is R by 2. Here, two resistors with value of R, and the value of capacitor is 2C here. And this is here where we give the input, and this is connected to the op-amp non-inverting terminal, and feedback is given back to this. So this is working like a voltage follower circuit. Now how to design this circuit? Say I want to design twin T-notch filter with FC, the central frequency equal to 50 Hz. So the formula for FC is 1 by 2 pi RC. We will assume the value of the capacitor here as 1 microfarad and FC is equal to 50 Hz. Then you calculate the value of the resistor, that is resistor R equal to 1 divided by 2 pi C multiplied by FC. So you will get the answer as 3.18 K. That is R equal to, in this circuit, R equal to 3.1.8 K and C equal to 1 microfarad. Now coming to the designing part, I will go to the new design here. Okay, so as I showed the circuit, we actually need one op-amp. So I'll bring one op-amp here. The op-amp is available in the analog group. Under that analog virtual, op-amp 3T virtual you can choose here. So I'll place that op-amp in my schematic. Then I need resistors. So I'll go to basics, resistor. I choose any value, no problem, then I will change the values. So 2 resistors in series. I need one more resistor somewhere here. Then I need capacitors. So I'll bring a capacitor. One capacitor here, another one, and one more. Now we have to we need one function generator to give the input. So that function generator is available here. You can bring this function generator, you can place it over here. You can rearrange these components as you wish. Okay, so this input. I need one oscilloscope. 2 channel is enough oscilloscope, which I will place here to observe the output waveform. Now you can connect these components according to the requirement. Capacitor be connected to the junction. This resistor should be connected to the junction. I need ground. So you go to sources, power sources. Under that ground option, you can pick If you want some more options, you can place it over here. So this should be connected to the non-inverting terminal. Output should go to the inverting terminal. So we have a function generator here. The plus of that is connected to the resistor combinations. Negative is connected to the ground. Now this can be connected to the input. This is given to the output. The terminal of the oscilloscope is given to the ground. So we will change the values of the capacitors and resistors according to my circuit. So it is 1 microfarad with initial condition equal to, you can say, 0 volt. This is 1 microfarad. This is 2 times of that, 2 microfarad. Here the resistor equal to 3.18 kilo ohm, 3.16 I think it is, 3.16 kilo ohm, 3.16 K. This is half of that, 1.58 kilo ohm. The initial condition equal to 0. I will save this circuit design. As notch filter. Notch filter. I will connect one Bode plotter to this to check the AC analysis. Okay, we will set the analysis. Before that, we will place one connector, on page connector in the output side. We can change the name, suitable name we can give here as out. So we need to set the input. Input is 1 hertz, so 10 volt is too much. Let's say 2 volt peak to peak. Since we designed for 50 hertz, let us give this as some 100 hertz. We will check the output for this. Yes, I am getting a output waveform for 50 hertz. Channel B, you can set it. So the signal is passing. You can see here, over here. If I give the frequency as 50 hertz, what will happen? We will check. Now, as you can see over here, only one signal is appearing, that is input, and this red line is output. To see it properly, I think it is better if you change the color of this output line. You can change this color always. I'll make it white. You can differentiate this. Okay, if we run this. Now see this is 0, output is removed by the circuit. If I make the frequency as 500 hertz, now just see here, both the red line as well as white line we can observe. That means this circuit is allowing the signal with a frequency of 500 hertz with a maximum amplitude. If it is 50, the signal is rejected. It's a narrow band reject filter or a notch filter. Or if I make it 100, it will allow but with a low amplitude because it has got certain bandwidth. See this, the white line, low amplitude. If I make it say 75 hertz, yes, it is even lesser. 50 hertz, completely rejected. 50 hertz, see over here, it is completely rejected. Nothing, only input we can observe. So this is basically a notch filter which is allowed to reject only one signal, that is 50 hertz, a narrow band reject filter. Now you can observe even the AC analysis of this. So let me stop the simulation, set the analysis for AC sweep. This is fine, I believe. I think we can check this output as give this. Done. Now yes, you can see over here, this is the response what I am getting, and if I check it, the frequency, this is the frequency analysis, this is the notch shape what I am getting here, and this notch shape is minimum at almost 50 hertz. Almost 50 hertz. As you can see over here, almost 50 hertz, it is almost minimum magnitude I am getting for 50 hertz. That means this signal is rejected. It has got very narrow bandwidth. So this is narrow band reject filter designing by using multisim software. Thank you for watching.